so you need to go back and review it. Talking about a system of equations, got three variables and three different equations. You're going to work, method-wise, it's going to be the exact same thing you've done before. We've worked systems with substitution, we've worked systems with elimination. I'm going to show you how to do both with this. We're going to start out with, let's do substitution. And your main goal with substitution, what you're going to try to do is going to try, and well, with any method you use, you're going to try to eliminate one of the three variables. You're going to pick one equation, and my suggestion is picking the simplest one. Like, notice here you've got a single x, single y, single z. I would probably use this one for substitution or elimination. But with substitution, pick a single equation, solve it for, it doesn't matter, either x, y, or z. Once you get it solved for that single variable, you're simply going to take it and then plug it into the other two. And let me show you what's going to happen. We'll just solve it for z. It really doesn't matter. We'll solve this first equation for z by moving the x over and by moving the y over. So once I do that, I'll have z is equal to -2. Moving the x over and the y over gives you minus x minus y. Once you take and you substitute that in for z in the other two equations, you now have the second equation turns into 2x plus 5y plus 2. Instead of z, you now have -2 minus x minus y equals 2. And the last equation turns into -x plus 7y minus 3z will now be -2 minus x minus y. And I do want to point out again that I took one of the equations and plugged it into both the others. Once you clean the other two up, let me point out that you went from having three equations and three variables, to now notice there's no more z's. You just plugged in this for all your z's. Now you have only x's and y's, and that's the reason we're not going to have to spend a lot of time on that other lesson that you're going to do yourself, because it's this from here on down. It's the old stuff. 2 times -2 will be -4. 2 times -x is -2x, -2y. Combine like terms. 2x minus 2x actually cancels. That's nice when that happens. 5y minus 2y gives you 3y, and move the 4 to the other side. 3y equals 6. Cleaning up the other one, you get -x plus 7y. Distribute -3 equals 20. Combine your x's and y's. -x and 3x gives you 2x. 7y and 3y gives you 10y. Move the 6 to the other side, you get 14. That's what it cleans up to. Let me point out that, again, this was a rarity. This doesn't normally happen. Notice here that your x's cancel. Normally, you're going to have xy stuff equals a number, xy stuff equals a number, and then you're going to take those two equations, and you're going to use either substitution or elimination again. Since the x is canceled, we can look right here, and we can divide by 3, and we can say that y is equal to 2. That's part of our answer. Now that we know that y equals 2, everywhere we have a y, you can replace that thing with 2. Like in this other equation, notice I have x's and y's. Well, y is 2. So I now have 2x plus 10 times 2 is 20. It's 14. Move the 20 over, we get 2x is -6. Divide by 2, you get x is -3. That's another part of your answer. You now have the value for x, the value for y. We now only need the value for z. And here's the rule, guys. You can plug this in anywhere. It doesn't matter what equation you plug it in. Pick any of them. You can plug it into where you solved it for z. You can plug it into the bottom equation, x and y, to find z. You can plug it in here. It does not matter. This is usually the easiest place since it's already solved for z. Z is equal to -2 minus x, which is -3, minus y, which was 2. So that's going to be -2 plus 3 minus 2, which is -1. And that is the value for z. So your answer, usually you have an ordered pair. If you go back to the old material, you're going to have like an xy. Now you have an x, you have a y, and you have a z. This is called an ordered triplet. You have an X, Y, and Z. This is three-dimensional. If you actually went back and graphed this on a three-dimensional type graph, what you have here, if you cover up the Z, X plus Y equals -2, cover that up and you graph that, we know we can move the X over, Y equals -X minus 2, that's a line. Same thing here, that's a line. This is a line. These would be three lines if there's no Z's. Once you add that Z in, it's a three-dimensional line. Imagine taking a two-dimensional line like this and extending it 3 dimensions, kind of going backwards with it. A three-dimensional line, if you were to actually extrude that, I guess you could say, to pull that line back and make it three-dimensional lines, a three-dimensional line is a plane. Back from geometry, a plane is a flat surface. It's kind of like taking a tabletop and extending it forever in all directions. But these three equations, and we're not going to go real deep into this, but these three equations are the equations of a plane. A three-dimensional line, which is a plane. What we're looking for when we're solving systems, we're looking for the single point. See if you can picture this. You've got three planes going in three different directions. Maybe one of them's coming out. Maybe one of them's coming in at an angle. You've got three different planes going in three different directions. You're looking for the single point where these three planes cross. Maybe you've got, like I said, one plane coming out this way, another plane coming out this way, and maybe this point right in the middle is where they cross. And it's at the point -3, +2, -1. And for those of you that's never seen three-dimensional graphing, how in the world do you graph that? Try to think of this idea. You're used to XY graphing, to where you go left 3 and you go up 2 and you put a dot there. Well, how in the world do you add in this third dimension? How do you go left 3 and up 2? Then where do I go? You either come out or you go back. So a -1, you might be coming out one spot, and it might be lifted up above, or it all depends on where you let your positive and negative Z be. But that Z-axis comes straight out from your center of your XY axis. And you'll get into higher math courses, you'll get more into, okay, what's three-dimensional graphing look like and how do I do it. The same problem solved with elimination method. And whichever one you like best. The computer might say use substitution. I don't care. If you like elimination better, use elimination. If it says use elimination, use substitution. I don't care. So use the method that you like best. If you're going to use elimination, the whole premise behind it is the same. I've got to get rid of either X or Y or Z. The way that you're going to do it, pick one of your equations. Again, I highly recommend the simplest one. And we're going to pair that with the other two and try to eliminate one of the variables. We're going to take my second equation, 2x plus 5y plus 2z, and pair it with it. Plus z equals -2. And you're going to take your third equation, which is -x plus 7y minus 3z, and pair it with that same equation. You're using the single equation to eliminate one of the variables in the other two equations. Again, it doesn't matter if you eliminate X or Y or Z, but here's what matters. If you're going to take these two and eliminate X here, you've got to do the same thing here. Because what you want to end up with is two equations that have the same variables. Let's do something different. Again, by looking over here, do you see how easy it is already to eliminate those X's? If you add these two equations together, which is what you do for elimination, when you add these two equations together, the X's are already gone. -X and +X are going to cancel each other out. So let's eliminate our X's. And the way we do that, if you don't remember from Algebra 1, is we can take either equation or even both equations, multiply it by something, so that when we add the equations together, it cancels out. And in order to get my X's to cancel, since I have a 2X here, I'm going to take my entire second equation and multiply by -2. And I'm just going to do it like that just to save some paper. We then just add the two equations together. 2X and -2X cancel. 5y minus 2y gives you 3y, and the same as the last problem, 2z and negative 2z also cancel. That's rare. Normally you're going to be left with y stuff and z stuff here, but in this case, they both cancel and leaves you with 3y equals 6. Then you come over here and do the exact same thing. X's cancel already. 7y and 1y is 8y. Negative 3 and 1 is negative 2z. And 20 minus 2 gives you 18. Normally at this point you're going to have y and z stuff here and y and z stuff here. You would then take those two equations, and I'll work on it in a second where you have that. You would then take those two equations, come down here and use either substitution or elimination like the old method. But for now, divide by 3, y equals 2. And if y equals 2, then you have now 16 minus 2z is 18. Move the 16 over, negative 2z is 2, so z must be negative 1. And if y is 2 and z is negative 1, which is the exact same answers we got from before, pick any of the three. And in order for it to actually work for, one, it needs to work for all. You're looking for the point that satisfies all, and this is the simplest, so let's plug it into it. X plus y plus z equals negative 2 is your first equation. Plug in your y and z. You get, move the 1 and 2 over, and you get x is negative 3 again. So negative 3, 2, negative 1, again, is the point where those 2 points cross. 3 points cross. Next problem. Again, 3 variables, 3 equations. You're looking for the x, y, and z that you could plug into these equations that's going to make it true. But again, just a reminder, just because it worked for the first one does not mean it's going to work for all 3. In order to be a true solution, the x, y, and z point must work for all 3 equations. So if you're going to use, if you do come up, I don't think you will, but if you did come up on an ACT problem like this, and you're just going to plug answers in, make sure you're able to plug in all 3 and it works, not just the first one. Again, you have the option of substitution and elimination. Me personally, I like substitution 1,000 times better. You can do elimination, but I feel like substitution's quicker. So if you want to use elimination, I'm fine with that. I'm using substitution. Pick one of the 3, solve it for either x, y, or z. The first one would be easy to solve for z or y. The last one would be easy to solve for x, so it's your preference. I'm going to take the first one, solve it for z. So to solve for z, I'm moving my 6x and my y over. So I now have z is equal to 5 minus 6x plus y. And I'm going to substitute that in for z here and z there. And you have, in essence, gotten rid of one of your 3 variables. Your second equation is now 2x plus 2y minus 3. Instead of z, we plug it in, 5 minus 6x plus y. Your second equation, or third equation, is now turned into x minus 3y plus 2 instead of z, 5 minus 6x plus y. And there's your 2 new equations. Minus the z's. There's no more z's. And from here on down, it's just algebra, just clean up. 2x plus 2y, negative 3 times 5 is negative 15. Negative 3 times negative 6 is positive 18. Minus 3y equals negative 16. Keep your x's and y's together. You have a total of 20x minus y. Move the 15 over equals negative 1. So you have just x, y's equals number. Third equation, second equation, do the same thing. X minus 3y. We'll draw a line to separate those. That'd be plus 10 minus 12x plus 2y equals 9. X minus 12x gives you negative 11x. Negative 3y plus 2y gives you negative 1y. And move the 10 over and you get equals negative 1. Okay, so once you get to this point, you've now, again, you plug z in, you've eliminated, you have only x's and y's. You take the 2 equations that you have left. It doesn't matter if you use substitution. It doesn't matter if you use elimination. You could even graph these 2 and see where they cross. I don't suggest that. But I'm going to use elimination. Since I've already got them x, y number, I'm going to line them up and use elimination. 20x minus y equals negative 1. Negative 11x minus y equals negative 1. When you're using elimination, in order to add these and get them to cancel, you need opposites. Notice you have a negative y and a negative y. So I'm going to go through and multiply everything in the second equation by negative 1, and that's going to be easy. That's just going to change the signs. That gives me a total of 31x. Negative y and positive y cancels, equals negative 1 and 1 is 0. When you divide by 31, you get x is 0. That's the first part of your answer. Once you get this, you go back and you plug it in anywhere you want to find a y. The only issue is if you try to plug it in up here, x is 0, you're going to have y stuff and z stuff, and you can't isolate y. So you really need to plug it in either here or here. We'll plug it into this one. Negative 11 times 0, that would be 0 minus y equals negative 1. Divide by the negative 1, you get y is 1. You now have an x and a y. Once you have x and y, go back to one of your originals or over here. Plug that in for x and y, and you now have z. Z equals 5 minus 6 times 0 is 0, plus 1, which is 6. So x is 0, y is 1, z is 6. That's the point where the 3 cross. Okay, here we go. Again, substitution elimination does not matter. If you're going to use elimination, and you'll notice on these I use substitution most of the time, but if you're going to use elimination, pick one of the 3, pair it up with the other 2, and eliminate something. X's or Y's, or Z's, doesn't matter. I'm going to use substitution. I'm just going to switch these two. I guess it's going to be the easiest route. And when you do that, you're going to have z equals x minus 2y minus 2. You're going to plug that in for both z's. So your second equation is now negative x plus 6y minus 3 times that. And you can go ahead and distribute if you feel comfortable. Your last equation will be 2x minus 11y plus 5 times that equals 11. Clean up, and I'm gonna skip a step here. As I distribute, I'm gonna go ahead and combine it. This will be x and negative 3x, which will give you negative 4x. This will be 6y and 6y, which gives you 12y. This will be positive 6. When you move it over, you're going to do minus 6, so that equals negative 12. Second one, you have 2x plus 5x, that will be 7x. Negative 11y and negative 10y will be negative 21y. Negative 10, when you move it over, will be plus 10, so that gives you 21. Word of advice. The same way, and this goes for not just these, but any of them. The same way you reduce fractions, you can reduce equations. I highly recommend doing that. Here I see a 4, a 12, and a 12. All 3 of those are divisible by 4. Clean that linear equation up. Divide everything by negative 4. Gives you an x minus 3y equals 3. That looks so much better. Divide here everything by 7. Gives you x minus 3y equals 3. Which is the exact same equation. When you go back, and you can try to use substitution or elimination, let me show you what happens. If you take x minus 3y equals 3 and pair it up with x minus 3y equals 3, and you try to do elimination, multiply everything by negative 1, you get 0, everything cancels. 0 equals 0. Anytime you come out with a 0 equals 0 or a true statement, all the variables cancel, but you come out with a true statement, that means you have infinite answers. There's not just one answer, there are millions of answers. Infinite answers. Before, back in Algebra 1, you stopped there. And you said that this was consistent because it had an answer, and you said it was dependent because it had infinite answers. We're going to go a step further this year. We're not only going to say it has infinite answers, but we're going to list all the answers. So make sure you have plenty of pencils, and paper. It'll take a while. Not really. Here's how you list them. Okay? We're going to list them as a point. Before, our point looked like 0, 1, 6. We knew an exact answer. There's X, there's Y, there's Z. We're going to write our answers like this. You're going to pick a variable, and you're going to write all your answers in terms of those other variables. Let's see, we got x minus 3y equals 3. Let's see if we can do it like this. We're going to write all of our answers and you can do any of the variables. We're going to write all of our answers in terms of, let's just say y. Just pick one of the variables. Look at this equation. X minus 3y equals 3. If I were to move that 3y over, does everybody understand this? X equals 3y plus 3. That shows you the relationship between x and y. X is equal to 3y plus 3. Y is equal to itself always. This is x, y, and z. And again, we're trying to write all three in terms of one of the three letters. Z, hey, look up here. Z was equal to x minus 2y minus 2. Well, I want my z to be written entirely in terms of y's. So here's what you do. Well, x is this, right? X is 3y plus 3. So up here where you have an x, put 3y plus 3. Very similar to the method that you used before. So now your z is equal to 3y plus 3 minus 2y minus 2. Combine like terms, you get 3y minus 2y is 1y. 3 minus 2 is 1. So z is equal to y minus 1. So that's your answer in terms of y. That's all your answers. And that was kind of scattered, and that's the part that's going to take some getting used to. But let me show you this. You can pick anything you want to for y. Because, again, this is infinite answers. What if y is 2? If y is 2, you get 6 plus 9. Or 6 plus 3, excuse me. Y is 2, and y minus 2 is 1. That's one of the answers. What if y is 4? Then you get 12 plus 3, 15. Y is 4. Y minus 1 will be 3. That's another answer. And you could actually use this by plugging in anything you want to for y. You could get a whole list of possible answers there. If y is 1, you would have the answer 3 plus 3 is 6. Y is 1. 1 minus 1 is 0. And that tells you all the different answers. At that point, and usually the computer is going to tell you what it wants you to write it in terms of, x, y, or z. If I wanted to, I could have solved this right here for y, and it would have been in terms of x. So you could have said, okay, I want to let x, I want to let everything be in terms of x. This is another way you could wrote your answer. If you want everything in terms of x, take this equation from before this, well, let's do it over here. X minus 3y equals 3. Solve it for y. Move the x over, you get negative 3y equals negative x plus 3. Divide it all by negative 3. And you get your y value. You see your y value is now in terms of x. Your y value would be negative x plus 3 divided by negative 3. Your z value. You could take that y value. I'm not going to do it because it's pretty ugly. I could take this y value, plug it in here. Then my z is in terms of all x's. And you put that there. Then you would have your x, y, and z all in terms of x. And you could choose anything you want for x. And that would give you a whole list of your infinite answers.